Okay, I am now going to attempt to give you a model research presentation. This is based upon a talk I gave a couple of years ago in the Communication Sciences and Disorders Department here at WVU. And I'm just going to go through all the steps of trying to clearly outline what my research project was about and what I found. And this particular talk was given to an audience of speech language pathologists and audiologists who are going to know something about phonetics to some extent, but maybe not too much about linguistics or phonology. And so that's what I'm shooting for here, is to introduce all the phonological concepts from the ground up. And then the time I'm shooting for with this talk, I think, was 25 to 30 minutes. So let's see if I can do that as well. And yeah, let me get started here. And then afterwards, you can assess how I've done on this research presentation. So what are some things I did right? What are some things I did wrong? What would you have done differently? Actually, if you feel like sending those to me, you can do that too. But it might be worthwhile just as an exercise for yourself, thinking about which aspects of a presentation you want to focus on when you're preparing that presentation. So without further ado, here is my research presentation. Today I'm going to be talking about segmentation and phonetic naturalness. And this is collaborative work with my colleague Melinda Fricke from the University of Pittsburgh. Here's what this project is about. I'm going to show you evidence today that certain kinds of lenition phenomena, and I'll explain what that is shortly, aid listeners in detecting repeated units within a speech stream, kind of like words, that this facilitation effect goes beyond the mere presence of a phonological pattern and actually is related to the phonetic content of the kind of sound pattern included, and that this facilitation effect that's associated with particular phonetic content seems to be at least partially independent of prior linguistic experience. So this can't be straightforwardly learned from native language experience. Here's how the talk is going to be organized. First, I will tell you a little bit about lenition and word segmentation. And so I'll talk about what lenition is and where it appears in different languages, as well as a particular kind of lenition pattern that I'm going to be talking about today that I call continuity lenition. I'll also tell you how lenition is related to general principles of speech perception, and how I set out to test some of those connections using the word segmentation paradigm. In the second section, I'll tell you about the study that Melinda and I did, and this was a word segmentation study conducted on native English-speaking college students. And then I'll tell you about what we found and what I think that means for the theory of lenition and segmentation and speech perception. So first of all, what is lenition? Well, it is a large and heterogeneous class of phonetic or maybe phonological sound patterns in different languages, all of which involve some kind of articulatory or acoustic weakening. Weakening of what? Well, mostly of consonant sounds, although there are some things that people refer to as vowel lenition. I'm going to completely leave that aside today. And this weakening or lenition of consonants tends to happen in particular phonetic contexts, while in the complementary context, in other phonetic contexts, instead of weakening, we find a complementary strengthening of those same consonants. Those processes are referred to as fortition, and so normally for the kinds of sound patterns I'm talking about, you find lenition in complementary distribution with fortition. And this kind of pattern is typologically ubiquitous. So virtually every language that's ever been described by phonologists has at least one kind of complementary lenition fortition pattern, English being no exception. And yeah, these are just extremely common sound patterns across the world's languages. So here are two of the most common versions of this. This first one is possibly the most common lenition pattern in the entire world, and it's referred to as spirantization. What does spirantization mean? It means that there are certain consonants in these languages that in one set of contexts, which I'll refer to as the fortis or strong contexts, are realized as stops, in this case voice stops. But in some other set of contexts, which I'll call leanness or weakening contexts, they're instead realized as some kind of continuant. Now, the word spirantization suggests that the continuant ought to be a fricative, although that is actually very rarely the case in natural languages. Here's an example from Kinande, which is a Bantu language spoken in the Democratic Republic of Congo. And what you can see here is that Kinande has these consonants which, at the beginning of a phrase, or following a nasal consonant, as in the left column here, are realized as voice stops. So this word for bit by bit would be something like bolo bolo, or this word for perfect would be something like gere gere, gere gere. Or following a nasal consonant here, you find that this velar stop is in fact a stop, engemu, which means tax. But if you take the same consonants and put them in between two vowels internal to a prosodic phrase, you instead find that they're continuants. In this case, they're probably close to approximants. So there's another version of this expression bit by bit that begins with a vowel, and this one is pronounced olo. Similarly, if you take this perfect word and put it after a class prefix that makes it animate, this becomes a perfect person, and it's pronounced omurere with an approximant here. If you take this root gemu, which has something to do with tax, and put it after a verb prefix, you get eriemula. So this sound that's otherwise produced as a voice stop is produced as an approximant in between two vowels. This process, spirantization, is attested in just about every language family on Earth. So if you look through typological surveys, you'll find dozens of examples of languages with some kind of a spirantization process. And this includes some very familiar languages like Spanish, Japanese, and Basque, as well as a number of less studied and less well-known languages. This is just a very, very common pattern. Also sporadically happens in English. Here is a second lenition pattern. This is a voicing lenition pattern, and this one involves some obstruents that are realized as voiceless in these fortis contexts, which again is going to be at the beginning of a phrase for the most part, but they're realized instead as voiced in the leanness context. So again, in between two vowels is going to be the most common leanness context here. And here are some examples from Sanuma, which is a language spoken in South America. It's a Yanomamin language. And what you can see here is at the beginnings of words or probably phrases, you have these voiceless unaspirated consonants like ta, ba, ka, and tsa. But if you look in between vowels internal to a word, you find only the voiced versions of them, right? So again, we would say that there are voiceless stops in affricates in fortis positions, voiced ones in leanness positions, and so this is voicing lenition. This process or this pattern is not quite as common as the spirantization one that I just showed you, but it's still pretty common. So these same kinds of typological surveys, you can still find anywhere from 20 to 40 examples of this, depending on what exactly you consider to be a voicing lenition pattern. And this is quite frequent in Australian languages, as well as in the Tibeto-Burman languages, and in the Amazon and parts of Mesoamerica as well. You find this voicing lenition pretty widely cross-linguistically. So these are very common patterns. And both of these very common lenition patterns share an interesting set of features. They canonically affect domain medial intervocalic consonants. We saw that with both of these. They might also show lenition of consonants in other positions, but if they do so, they always also affect the intervocalic ones. This is really the main context where lenition happens. Both of these processes involve an increase in the intensity of the consonants in question, or a decrease in duration, or both. Right? And these particular ones, as we've just seen, the lenition that we see in between vowels in both these examples was accompanied by inverse fortition domain initially, where the domain was either a word or a phrase, depending on the language, but we saw that there are fortis realizations initially within a word or a phrase. So there are other lenition processes out there, or other patterns that some phonologist at some point has referred to as a lenition pattern. that may or may not have all of these properties, but I'm going to limit my discussion today to the cross-linguistically very common kinds of lenition that meet these three criteria. And I'm going to refer to these as continuity lenition. And I'll remain agnostic as to whether other kinds of lenition are the same or different from these ones. I'm limiting my attention to these particular continuity lenition types of patterns today. These are by far the most common lenition patterns that everybody tends to agree are correctly referred to as lenition. So here is a theory of how continuity lenition works, or why it is the way it is. And this comes from the theoretical phonology literature. The idea is that this kind of continuity lenition emerges from very general properties of acoustics and speech perception. That is, it reflects pressure to align points of auditory disruption with structural prosodic boundaries. How does that work? Well, within a prosodic constituent, leniting a consonant and making it more intense and more like the surrounding vowels is going to preserve auditory continuity within those prosodic constituents. Right? So for spirantization, for instance, within a stream of vowels, stops are going to disrupt the flow of energy more than continuants do. So realizing these consonants as continuants makes the speech stream less disrupted and more acoustically continuous. Right? Same thing for voicing here. In between some vowels, if you have a voiceless obstruent, it's going to be more disruptive than a voiced one because it's more dissimilar from the surrounding vowels. So it's going to create greater perceptual auditory disruption. So having stops and having voicelessness are good for marking boundaries because we're trying to align auditory disruption with boundaries. And indeed, that's what we find domain initially in phrases, and in some cases words, while continuants and voicing are going to be good for marking the lack of boundaries. And indeed, that's what we saw in these examples. Internal to a prosodic phrase or a word, we found these lenition processes. The basic idea here, points of auditory disruption should be aligned with structural discontinuities, that is with phrase boundaries, while points of auditory continuity should be not aligned with structural boundaries. They should be continuous within a structural constituent. Why would lenition work this way? Well, the hypothesis from those papers I just mentioned is that aligning points of auditory disruption with and only with prosodic boundaries should help the listener in prosodically segmenting the speech stream. So this is hypothesized to be a listener-oriented type of sound pattern. And the idea is that you create an isomorphism between the auditory stream on the one hand and the prosodic constituent structure on the other hand. So the idea is that low-level auditory processing should feed useful information to the sort of linguistic cognitive component in order to help zero in on possible structural boundaries. This is going to be related to a much broader idea about domain general Gestalt grouping principles, not just in the domain of languages, but also in the entire auditory domain, including music and other auditory stimuli, and potentially in the visual domain as well. These kinds of proximity and similarity principles have been hypothesized to govern all sorts of grouping and segmentation type processes in many domains of perception since the 1910s or so. Right? So this is a much broader idea than just lenition. It's this general Gestalt grouping idea. One really basic prediction of this theory, or really an assumption of the theory, is that lenition and fortition patterns, these complementary patterns, should make it easier to detect constituents. After all, it says that that's the whole reason why these sound patterns exist in the first place. Yet there has been essentially no test of this anywhere in the psycholinguistic or phonetic literature. So we set out to test whether this actually works or not. And we did this using a task that probes constituent detection, in particular, the word segmentation paradigm. So let me tell you a bit about how this works. Right? Here is a finding from the last 30-ish years of psycholinguistics. Even given very little exposure, humans quickly learn to discriminate statistically coherent sequences from sequences with less statistical coherence. And this is famously was reported in the journal Science in the Safran, Aslin, and Newport paper using 8-month-old infants. There have been many follow-up studies showing similar things in a range of age groups for native speakers of different languages with different kinds of artificial languages and materials and designs. We are going to use the experimental paradigm from Frank and colleagues as a starting point here. What we're basically looking at in word segmentation tasks is whether sequences of syllables that always follow one another during a training phase, and we'll refer to those as words, whether those words can be discriminated from sequences of syllables that sometimes but not always follow each other. And so we'll say that those sequences of syllables straddle word boundaries, where of course the words are made up here, but they're meant to be statistically coherent in the way that words or morphemes or phrases in a real language might be statistically coherent. So given that we have a whole bunch of experimental results previously showing that subjects can do this task, that they can effectively track these patterns of statistical coherence and identify fake words in a novel language, here's our question. Is it easier for them to learn and identify words from these fake languages when the statistical regularities are reinforced with Lenition-Fortitian patterns? Our theory of Lenition-Fortitian suggests that it should make segmentation easier. We have this task where people can learn to do segmentation. The question is, does the Lenition-Fortitian pattern help them do this segmentation? And this is going to be compared to an anti-Lenition pattern. That's sort of the exact opposite of the spirantization and voicing patterns I just showed you. That anti-Lenition pattern is, as far as I'm aware, not attested in any human language. Right? So it's going to be statistically identical to the Lenition condition, but the actual sounds involved will be the opposite. There's a secondary question we set out to ask here, which is, does the magnitude of the acoustic difference between the lenis and fortis, or initial and medial consonants, does that difference matter? Right. So that's going to be a second question. All right, so what did we do? First, we made some syllables. We synthesized these in a more recent Unix software updating of the KL-SYN synthesizer, which allows you really fine-grained control over acoustic details in speech synthesis. And we based these syllables on the formant targets and transitions in consonants and vowels from a few tokens of Madrileño Spanish, which does show this kind of spirantization pattern, where the actual formant transitions from those targets to one another and the amplitude of the stimuli as well were based on Dennis Klatt's original Klatt cookbook manual for the synthesizer. We tried using more naturalistic Spanish values for those functions, and they did not come out sounding good, so we went back to the original Klatt instruction manual, and that worked better. We held F0, the pitch of these was flat at 165 hertz, and we kept the duration of all the consonants and vowels and transitions steady across all syllables. So there's absolutely no cues here to prosodic constituency or stress or anything like that. Here are three examples of words from each of our three conditions here. This is the anti-Lenition condition, so this is going to be with an initial continuant and medial stops. Here's one from the Lenition 1 condition. This will have an initial stop and medial continuance. These ones are slightly less vowel-like continuance. And then this Lenition 2 condition is the same, but it has slightly more vowel or approximant-like continuance. Okay, those sound almost like glides, right? So this is a less Lenition and more Lenition condition, as well as the anti-lenition condition. Each subject in the experiment went through a training phase at the beginning of the experiment, and this was really minimal. It was just put the headphones on and listen to this continuous stream of syllables. Now, we didn't tell them that the syllables were organized into words. We just told them they were going to listen to an imaginary language. There was absolutely no acoustic division between the words. It's just a continuous stream of syllables, except that every 4 words we mark with a pause this unit that we're going to refer to as a sentence. So it's 4 of these words randomly concatenated, separated by a pause, and that's meant to simulate, a sentence or an utterance or something like that. Each subject was exposed to about 600 words in total. There are 150 sentences with 4 words each. And this took about 8 minutes for most subjects. There were 6 different words in these made-up languages, and so they got 100 tokens of each word, and we used a mix of 2-syllable words, 3-syllable words, and 4-syllable words. Subjects were instructed to listen carefully to the training phase, but no attempt was made to enforce that. They weren't given any task to do. This was really just passive listening, right? And it's been shown to work with adults and other experiments, and so this is the way we set the task up. Here are our 3 there's 3 conditions. I'll show you 2 of them here. This is the anti-lenition condition, where there's 6 words, each of which begins with a continuant, and where all medial consonants are stops. So this is the opposite of the real spirantization pattern that we find in natural languages, and it's unattested as far as we're aware in any natural language. The lenition pattern instead looks like the Kinande examples I showed you earlier. It has stops in initial position and continuance medially. Now, we also did this in the more lenition, or lenition 2 condition, where these were more like glides, and the lenition 1 condition, where they were, maybe more like a liquid or something like that. Excuse me. These 6 words were randomly concatenated into 4-word sentences, and then they were played a sequence of 150 of those sentences in a random order. So here is just 3 sentences from the lenition 1 condition, and this is what a sentence sounds like in this experiment. So absolutely no acoustic separation between words there. Here's another one. And here's a 3rd sentence. This is not particularly easy task. It's not very easy to hear where the word boundaries are. And then after this 8 minutes of training, the subjects are asked, hey, here are 2 words, and these were presented not in writing like I've done here, but auditorily. And we asked them, hey, which one of these is a word in the language you just heard? So as you can imagine, subjects were pretty confused, and they weren't sure they were able to do the task. But the miraculous thing about these word segmentation tasks is even if they don't know they're learning, they actually have learned. Right? So here's how we're going to measure whether they've learned the words or not. We're going to ask whether participants can discriminate words from non-words. And we also are interested, obviously, in whether they do this more readily or more accurately in the lenition conditions than the anti-lenition condition. So here's how we decided to measure sensitivity to this word-non-word distinction. We looked at the response, the second one is a word, and we asked about the difference of people's likelihood of responding that way when the second word actually is the word versus when the first stimulus was actually the word. So this is going to be the difference between hits and false alarms, and we're going to model this using a mixed effects logistic regression model. Here's what we find in the spirantization context. This is going to be the sensitivity. Again, this hits minus false alarms in the anti-spirantization condition, in the first spirantization condition, and the second spirantization condition. And as you can see here, subjects in the lenition conditions were much more likely to learn the words from the exposure phase as compared to subjects in the anti-lenition condition. In other words, it was easier to learn that sequences like dua were words than to learn that the complementary luba sequences were words. despite the equivalent statistical coherence. Although it's worth noting that even in the anti-spirantization condition, most subjects still did show some learning. So this is above zero. We'd expect it to be zero if they learn nothing. But they just learn better in the spirantization conditions. There's not much of a difference between the two lenition conditions, maybe a tiny difference, but not statistically significant. And this might mean that once some criterion difference between initial and medial consonants is reached, having more lenition just doesn't help. Or perhaps what's most important is simply the presence of some kind of disruption word initially, regardless of what the medial consonants are like. But the overarching message here is that spirantization patterns gave rise to a learning bias in cases where auditory disruption coincides with hypothesized word boundaries. This is exactly as we had predicted in our hypotheses. So everything is beautiful, right? Until you get to the voicing results. And here we got no difference whatsoever, or very little difference anyway. The difference here for voicing lenition, and this was just like the spirantization experiment, except instead of stops and continuants, we used voiceless and voice stops and fricatives. And we found that the difference between the lenition and the anti-lenition condition is negligible. So it looks like this voicing effect alone doesn't actually aid segmentation. Well, we did show that subjects learn strings on the basis of transitional probabilities better when boundaries between cohering units are reinforced by phonetic disruption in the form of continuancy alternations, but not voicing alternations. So only one of the two lenition patterns that we'd set out to test here turned up meaningful results with regard to the segmentation task. What could be going on here? Well, we have a number of ideas, and I can talk about these in the question period if you're interested. But here's some ideas. Maybe this voicing manipulation is just much less salient than continuancy or something like that. So maybe, the voicing manipulations do help segmentation, but you just need a much more powerful task to detect that because they're not as salient as the spirantization ones. Here's another idea. Maybe real voicing lenition in actual natural languages doesn't just involve voicing. Maybe it always involves some element of duration or continuancy in addition. And there are some suggestive results from the phonetic literature suggesting that languages described as having voicing lenition may actually have a number of other things going on as well. A final possibility here is, well, maybe subjects have experience with spirantization in English. These are all native English speakers, the subjects, but maybe they don't have experience with voicing lenition. We've done some follow-up analyses, and based on those, we think that the first or second explanation here is more plausible than this third explanation. Based on what we're seeing, we don't think that this could be directly related to experience with English spirantization. But again, ask me if you're interested. I can talk about this during the question period. Many thanks for your attention today. I also wanted to thank our colleagues who helped us with the conceptualization of this project and also with some feedback on our first set of results. This is Melinda Fricke, my co-author, who is an assistant professor at Pitt Linguistics, and she also had a giant role in this project. So thank you very much. All right, how did I do there? Oh, I forgot to time this. Well, I'll check it afterwards, but I think that was under 30 minutes. Oh yeah, so that was about 25 minutes. I ran a little bit long. Normally it's a good idea to keep up a timer while you're giving these presentations. But that was my attempt to show you what a well-organized research presentation looks like. And, part of this was to show you that, look, this is something everybody can do. But part of the point of this exercise as well is for you to look through this presentation and think about what could Professor Katz have done differently? What did he not explain clearly? What was I thinking about while he was going through this part of the presentation? What are some of the elements that he could have included here that he didn't include? What were the helpful elements in here? So I wanted to give you just an example talk for you to break down if you're looking at the criteria that me and Dr. Robles Puente have given for having a clear research presentation. I just wanted to show you how some of that is put into practice and also give you an opportunity to critique that and see what could have been better about this. Normally, at this point in the semester, you would be preparing your own research presentation for the class, and sadly, we're not going to be able to do that this semester, but the hope here is that you'll be able to look critically at this research presentation and get some of the benefit of thinking about the organization of a presentation like this. Thank you.